Hey students, on this clip we're going to go over some of the questions that you will be seeing on the exam, on the chapter test. So let's go ahead and write down the title of these notes. Unit 4, test review problems, test review. Alright, so let's take a look at number 1. Number 1, we're asked to find the cube roots of negative 27i. Okay, so we're looking for all the cube roots, not just the principal roots. So if we want to find all the cube roots, we're going to have 3 answers, okay? So first thing we're going to do is express this in a plus bi form. Okay, I want to express this in a plus bi form so I can know what the a and the b are. So this is going to be 0 minus 27i, okay? So 0 is my a or my x, negative 27 is my b or my y. Do not take the I ever, okay? So if I want to take the cube root out, I'm going to be applying that formula, that interesting formula, which is basically, let me write it on the side here, a plus bi to the 1 over p formula, which is r to the 1 over p times cosine theta over p plus 2 pi n over p for the cosine. And then also for the sine, we have the same thing, okay, with the I over there. So this is the formula I'm going to be using for this problem. So what I'm trying to show you is that in order to use the formula, we need to have this in polar form. So let's find r first. R is the square root of a squared plus b squared. So we're going to have the square root of 0 squared plus negative 27 squared, which is going to become 0 goes away, the square root of 27 squared. The square root of 27 squared is equal to 27. So that goes your r. Alright, so now let's look for theta. Theta is going to be the inverse tangent of a over b. C over a, or negative 27 over 0. Alright? So let's put that in our calculator and see what we get. Here's the TI-83. So if we take the inverse tangent of negative 27 over 0, which is an undefined number, we get an error message, divide by 0. You can't divide by 0, right? So whenever you have a situation when you have an error message like this, you have to actually figure this out by hand. You actually have to graph where this point is, okay? So we're graphing the point 0, negative 27. We're graphing this point on our coordinate system, and then that will tell me what the angle is going to be, okay? So where on earth is 0, negative 27? If I want to graph it, 0, negative 27 means the 0 on the x, and you're going to go down on the y, all the way down to negative 27. So that's negative 27 on the y. Because this is your x, and this is your y. Remember, this is x, and this is y. So what's the angular measure? You're going to go from here all the way around to there. How many degrees is that? This is 0, 90, 180, and that is 270 degrees. Alright? Guess what? Theta is 270 degrees, or 3 pi over 2. So theta is going to be 270 degrees. So if your calculator can't do it, whenever there's zeros involved, you can always use a graph to figure out what the angle is. Alright? So that goes r and theta. Now we're going to use the formula now. So 0 minus 27 I to the 1/3 is going to be as follows. It's going to be 27. Let's write it in polar form first. 27 cosine 27 cosine theta, which is 270 degrees, plus I sine 270 degrees. So we're getting the formula prepared for we're getting the equation prepared to use the formula. So this is the polar form of this based on what we just found. Now we're going to apply the formula, okay? So when we apply the formula, it's going to be 27 to the 1/3 times cosine 270 over 3, that's p, plus 2 pi n over p, which is also 3, okay? That one times, and plus I sine, the same story, 270 over n, 270 over p, which is 3, plus 2 pi n over 3. Close that, and close that. What is n? Since we have the 3 cube roots, we're going from n equals 0, 1, 2. Okay? We're going to go 0, 1, 2 for the n's. Well, let's simplify this a little bit further first before we start doing the different iterations that we have. So 27 to the 1/3 is the same thing as the cube root of 27, right? The cube root of 27. And then inside we're gonna have cosine 270 over 3 is 90 degrees, right? 90 plus 2 pi is 360. 360 10 over 3, like that. Plus I sine, the same story. 90 plus 360 n over 3. Close that, and then close that. Okay? What is the cube root of 27? Cube root of 27 is 3, so we're going to have 3 times cosine 90 plus, what is 360 over 3? 120, right? 120 n plus I sine 90 plus the same story, 120 n. So this is a nice formula. I can just simply plug in 0, 1, 2 for the n's, okay? And that will generate my answers for me. So let's start with n equals 0. For n equals 0, we're going to have 3 times cosine 90 plus 120 times 0 plus I sine, the same story, 90 plus 120 times 0. What's that? And 120 times 0 is go to 0. That goes to 0, that goes to 0. So my answer in rectangular form, in polar form, sorry, is going to be 3 cosine 90 degrees plus I sine 90 degrees. Okay? So what is this in rectangular form though? Where is 90 degrees on a unit circle? It's on the upper y-axis, right? So the point is 0, 1. Let's look at that unit circle real quick. 90 degrees right there is 0, 1. Okay? So since 90 degrees is 0, 1, let's put it on the side. 90 degrees is 0, 1. The x-coordinate is the cosine, the y-coordinate is the sine. So we're going to have 3 times cosine 90 degrees, which is 0, plus 1i. Okay? Because sine 90 is the y-coordinate. Distribute the 3, you're going to have 0 plus 3i, which is just 3i. Okay? Now, let's do n equals, we're going to do n equals 1. So this is my first answer in polar form. That's my answer in rectangular form. First two. Okay, so for n equals 1, same process. We're going to plug in 1 into the ends here, okay? So we're going to have 3 times cosine 90 plus 120 times 1. Yeah, that's right. Plus I sine 90 plus 120 times 1. Okay, and then close out the main one. So what is 90 plus 120? It's 210, right? So it's going to become 3 cosine, let me rewrite this. I to write the brackets well. 3 cosine 210 plus I sine 210. Alright? So there goes your answer in polar form. Alright, so we also want to express this in rectangular form, right? So to express this in rectangular form, we need to find 210 on the unit circle. If 210 is not on the unit circle, then we have to use our calculator, okay? So I think it's on the unit circle. So let's take a look. 210, bam, right there. Negative root 3 over 2 and negative 1 half. So 210 is negative root 3 over 2 and negative 1 half. So we're going to plug that in here. So you're going to have 3 times negative root 3 over 2 minus 1 half I. Because this is a cosine. Cosine 210 is the x coordinate. And sine 210 is the y coordinate. Alright, so we distribute the 3 to everything. These 2. So it's going to be negative 3 over 2 minus 3 over 2i. There goes your answer in rectangular form. Alright, let's do n equals 2. So for n equals 2, you're going to have 3 bracket cosine 90 plus 120 times 2 this time. Close that, plus I sine 90 plus same story 120 times 2. Okay? Alright, let's work it out. So it's going to become 3 cosine 120 times 2 is 240. So if I add 240 to 90, I'll get 330 degrees, right? So this is going to be 3 cosine 330. Let me write my 330 properly so you guys don't get confused. 3 cosine 330 degrees plus I sine 330 degrees. And that goes my answer in polar form. Okay? Well, of course, I have to express this in rectangular form too. So what I need to find is 330 on the unit circle. I believe 330 should be on the unit circle. Going down backwards from 360. So let's see. Unit circle, 330 is right here. So there goes my coordinates for 330. Alright? Negative root 3 over 2 and negative 1 half. So we're going to have negative root 3 over 2 and negative 1 half. Remember, this is a cosine. This is a sine. So we're going to apply that here. So it's going to become 3 cosine 330 is negative root 3 over 2 minus 1 half I, like that. Okay? Alright, so distribute 3 to everything. Oh, wait. I messed up. I think one of them was positive, right? 330, one of them is positive. The root 3 over 2 is positive. So let's change the sign of the root 3 over 2. Take out this minus out of there. Take that minus. Yeah, take minus out of there. So that one's positive. So our answer is going to be 3 root 3 over 2 minus 3 over 2i. And there goes my answer in rectangular form. Okay? So that's that. Alright, let's move along to another example. What if I wanted to find the power of a number? Okay, number 2. We want to find negative 2 plus 2i to the 4th power. So what is that going to be? So if I apply the Morris theorem, it's basically going to be r to the n times cosine n theta plus I sine n theta. Alright? That's what it's going to be. So to do this, I need to find r and theta first, and then we can apply this rule. So let's look for r. R is going to be the square root of a squared plus b squared. So it's the square root of negative 2 squared plus 2 squared right? And then that's going to be the square root of 4 plus 4, which is the square root of 8, which reduces to 2 root 2. Okay? To find theta, we're going to take the inverse tangent of y over x, or inverse tangent of b over a. So it's going to be inverse tangent of 2 over negative 2. Since x is negative, we have to add 180, okay? Or 2 pi. Oh, I'm sorry, or pi. Add 180 or add pi. So that equals the inverse tangent of negative 1 plus 180. So what is the inverse tangent of negative 1? Let's have our calculator do that for us. Inverse tangent of negative 1 is, what just happened? Mode, enter, again, negative 45, okay? So it's negative 45, but we're going to add 180, right? Why don't we just add it while we add it? Negative 45 plus 180 should give me 135. So this is going to be negative 45 plus 180. And as the calculator just showed us, that's equal to 135 degrees. That is my theta. Okay? So in this problem, negative 2 plus 2i to the 4th can be rewritten in polar form as 2 root 2 cosine 135 plus I sine 135. Close that, all raised to the 4th power. So when we apply the Morris theorem, we're going to raise the absolute value, or the radius, to 4 and multiply these angles by 4. Okay? So let's do that. So we're going to have 2 root 2 to the 4th times cosine 135 times 4 plus I sine 135 times 4, like that. Okay? So what's 2 root 2 to the 4th? It's just like 2 root 2 4 times. If you do the maths, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16 times these 2's. Root 2 is 2, root 2 is 2, so 16 times 2 times 2, like that. 16 times 4 is 40 plus 24, which is 64. Alright, so we're going to have 64 cosine 540 plus I sine 540 degrees. There goes my answer in polar form. Alright? What if I wanted to express my answer in rectangular form? 540 is bigger than my unit circle, is bigger than 360, so I can't really tell. I need to spin it backwards to see if it can fall into my unit circle, okay? So, let's see. Hear that. So, what I'm going to do is let's go 540. A quaternion angle from 0 to 360 that is the same as 540 can be derived by just subtracting 360 from 540. Okay, so if I subtract it, 180 is between 0 and 360. So we can use 180 as our point. Alright, so is 180 on the unit circle? Of course it is. 180 is on the right side of the x coordinate, right? So negative 1, 0. So the coordinates is going to be negative 1, 0. Alright, so this problem is now going to become 64 times cosine 540 is the same thing as the cosine of 180, which is negative 1, plus cosine 540 is the same thing as sine 180, which is 0i. If you distribute 64, you end up with negative 64 plus 0i. Final answer is simply negative 64 for your rectangular form. Okay? Thanks for paying attention to this clip. Remember, it's uploaded on YouTube for your viewing pleasure.